All right. Any questions about anything else? Because I'm actually gonna let y'all go early today, so I can do my little administrative stuff, like making
Can
a
we do
schedule.
like one or two of the other kind of problems?
I thought about it, and yeah, sure. Let me stop playing. You know it's Friday. That's my day to wild
Wait,
out.
what was your question?
So I wanted to do one of the who can whoever I think that was you, Sage, with the black arrows. Can you erase those? Thank you. She wanted to do the one of the questions where you add HX to a double bond. I mean, conjugated diene. Is that right, Sydney?
Yes.
All right. So we can do. Actually, we did some of these last night. Let me find the one we did last night. Let's see. Yeah, here we go. Yeah, I want to do this one especially. Number one. Yo, man, come on, yo. So it says write out the products of 1, 2, and 1, 4 addition of HBr and BR. We're going to skip uh, the DBR because that's just deuterium, and it doesn't. There's nothing different happening there. 2,1,3-cyclohexadiene. That's my chart material. What does that look like? What based on the name? Let's break down the name and see if we can figure out what that looks like.
It's
Is
a
it a
ring.
ring?
Yes.
It is a ring because of the cyclo part. What about the hex? How many carbons in the ring?
6.
6.
6 carbons in the ring, so it's going to be a 6-member ring like that, right? And then
That's 2 double bonds on 3 and 1 and 3.
mm-hmm. So there's 1, 2, 3, and then 4, right? And
What is wrong with you?
I don't know. All right. So that's how my double bonds are numbered. You can see where the 1, 3 comes from because you always give the double bond the lowest number possible as far as its location is concerned. All right. So let's do this. Let's take this. And let's get some blank space so we can work it. Uh-oh. And just for the interest of time, we're only gonna do one of the double bonds. So let's pick this one. That okay?
Yeah.
And if you want to do the second one, you can work through it on your own time. So let's take that one. So we're gonna go through the mechanism. So we're gonna attack the HBr. Based on that, we're gonna get an intermediate. And what do we know about the intermediate? What does it have to be? There's a requirement for this reaction, this particular reaction about the intermediate.
The plus charge must be next to the other double bond.
There's got to be allylic, right?
Yeah.
All right, so that's my intermediate, and then here's Br hanging out here. What do we know about? I hope I can get over there. Yeah, I don't have enough room. What do we know about this reaction now? What is the? Sorry about that. What is the 1,2 product and what is the 1,4 product? How do we show that?
The 1, 2 is direct.
It's gonna come right here, isn't it? Straight to where the plus charge. Well, let me fix that arrow. Straight to where the plus charge is, to that carbon. Right? So the 1,2 product is gonna look like that. Is that right?
Yes.
And then the 1,4 product, where's the bromine gonna attack in that case?
The double bond.
It's going to attack here, isn't it? And then cause that double bond to shift over. So for the 1,4, this is the product. Is that right?
Mm-hmm.
Does anybody not see that? How that's the 1,4 product? Any questions about that?
Oh, okay. Why is the bottom of the 1,4 product?
All right, so when we look at the conjugated diene, right? If we're using this double bond, right, we can number it like this: 1, 2, 3, and then 4, right? So when I make the intermediate, which is down here, and the plus charge is on carbon 2, do you see that?
Yes.
So that's when the bromine attacks there, that becomes my 1,2 product,
Taking it 2. Yeah.
right?
Mm-hmm.
And then when the bromine attacks at the other side, right, at carbon 4, can you see that? Let me go back up here. You see how this carbon right here is carbon 4?
Yes.
And then right here is the same carbon, right? And so when bromine attacks there, that's where I get my 1,4 product from.
Okay. I understand. Thank you.
All right, yep. All right. Now the question also asked about if I did that same reaction with bromine. So let's talk about that, because I think there's a question on the test that uses bromine. If I use Br2, and we're gonna keep it consistent, still use the same alkene to react. What do I get when I add Br2 to an alkene? Anybody
Won't you
remember?
get 2 products?
Say again.
Won't you get 2 products or 4?
Well, you always are going to get 2. If it's a conjugated diene like this one, you're going to get 2 products anyway, right? But when I add the Br2 to the alkene, what does the intermediate look like? That's what I'm trying to get at.
Oh, it's the little ring, isn't it, with BR?
Yep. Yep. So let's put the arrows in. Let me draw this out too. So this is Br, and then this is going to attack here and break the bromine bond, right? So I end up with this. But the intermediate looks like this, Br plus, right? Y'all remember that from part 1?
Yes.
It's called a bromonium ion,
Mm-hmm.
right? And so now we still have our 2 pathways open, right? The 1,2 pathway, this is carbon 2 right here, and then this is going to be carbon 4 up here, and it still follows the same mechanism, right? So the other bromine, it can attack at 2, like so. Pop that ring open. Is that right?
Yes.
What do we need to show for that product with respect to the bromines?
Trans
You
stereochemistry.
got to be trans, right? That's a hallmark of that reaction, is that the stereochemistry is trans. So I'm gonna put this one down like that. I'm gonna make this one wedged. Like that. Is that okay?
Can you scroll back up for a second?
I'll just zoom out.
Right.
All right. Any questions about that particular product?
Nope.
So what happens when bromine attacks at the 4 position? What do you think is going to happen?
The double bond is gonna go to the left, which would then it'll be
That it's going to be the shift of the double bond that causes this ring to open. Is that right?
yes.
So what does that product look like? Let's see. We can figure that out.
It'll be one at the top and one at the bottom.
So you got the 6-member ring here. The double bond move to here, and you got a bromine here and one here. And just for the sake of continuity, we'll keep them trans. That okay? You're still going to get the same 1, 2, and 1, 4 addition. All right. Any questions about that?
Nope.
All right. So we're gonna. It's 9:47. We're gonna stop here. The test I'll put up this afternoon while I'll be getting that together while I'm chopping these videos up, because I gotta chop up today's video, last night's study session, and Wednesday's lecture, so you can have that to refer back to while you're taking the test if you need it. The test will only be Diels-Alder and addition of HX to conjugated dyne. So it's only over conjugated dynes, right? And then next week we're gonna do aromaticity. We're gonna spend about 2 days on that, and then we'll take another. That won't even be a test; it'll really be a quiz. But in order for that to work properly, you gotta watch the video that I send you. I'm actually gonna send it today. So it'll give you can watch it in pieces over the weekend, because I think it's like a 10-minute video. But everything that's in that video is going to be necessary for next week. So you got to at least do that, or at least go to the syllabus and look at the section on aromaticity and read that section in the book. But it's got to be one or the other. And I can show you what a handout is. Let me go ahead and get that out the way, because there's a handout for this aromaticity. Where is it? I thought I had that handout on here. Oh no, never mind. It's not here because it's not an assignment. It's just a handout. But I'm gonna post it in here because it's got all the reactions on it. All right. Any questions about anything before we get off?
Nope.
Let's see what this is. Oh, it's in here. Yeah, it's right here. So I'm gonna post this handout here, and I'll post the other handout that has some questions on it. Let me see. Unless this is the same thing. And then that way we can follow along, because there won't be a whole lot of problems associated with this, because we're not going to spend too much time on it. We're going to hit it. I'll give you the essentials, and then we're going to move on to the next topic. All right. Any questions about anything? before we, that's the same thing. No questions. All right, cool.
No.
All right. So let me stop this video.